All right. Hi, everybody. Welcome to AROYA Office Hours. My name is Keisha, and I'll be your moderator for today's discussion. A couple of reminders before we get started. This hour is your chance to hear from the experts, get answers in real time about data you're seeing with your grow, and share cultivation tips and tricks with other growers in this exciting industry. We thank everybody in advance for not using this time for things like airing policy or industry grievances or asking about AROYA pricing, although you are always welcome to book a demo. Feel free to type any questions you have in the chat at any time. And if your question is selected, we'll have you unmute yourself and ask away. Plus, as a special treat, we're sending an AROYA hat to anyone who asks a question for the first time during today's live session. We are limiting that to U.S. residents only and one hat per household, but excited to talk to all you great growers out there. Jason and Seth, are you ready for our first question from Instagram?
Yeah, thank you, Geisha.
Yep, thanks.
Awesome. Good to see you guys. Okay, we're just going to get right to it. This one is from No559. They are new to crop steering, and they want to know, for a first timer, how would you recommend they get started?
Always get started checking your environment conditions. And I know that sounds a little funny because we say, hey, we're really excited to jump into crop steering. With the AROYA system, we're always looking at that environment first before we really dig into how we're trying to manipulate our drybacks. So drybacks just really transpiration, making sure that our irrigation windows are appropriate for our plant size, for our substrate size, for the stage of growth for that plant. So go in, make sure your VPDs are where you want during that phase. Make sure that you're using a temperature that you're really trying to achieve. Look at your VPD and then modulate your humidity based on that target temperature. Obviously, sometimes we don't always have full control over humidity. So maybe if we don't have a humidifier or we don't have enough HVAC capacity to dehumidify, we can modulate our temperature just a little bit to strive for the appropriate VPD. And that's the absolute first step, because once we have that environment set up, then it's going to be way easier to do crop steering, the planning for crop steering. So if our plants aren't growing as optimally as they can because of the environment, we're always going to struggle to modulate crop steering. And if we take that a little bit farther, sometimes clients are in greenhouses. Maybe they don't have enough supplemental capacity. Maybe they have no supplemental capacity at all for lighting. And that's also a scenario where it's going to be definitely trickier, because your daily drybacks are not going to necessarily be projectable from the day before. You may need to modulate your irrigation schedule based on outside environmental factors.
Yeah, I mean, I think you nailed it, Jason. Making sure your environment is capable, or you have the control capabilities to modulate everything in your environment so that you can achieve those goals. Because if you don't have humidity control, you can't control your dryback, or you won't dryback. You know, if you hit week 4 and you're at 80% day and night, like we're not going to be able to achieve much. That's a reality, and that's a sign of where you need to start putting your money and figuring out, what's more important in this grow, because we can try to crop steer all we want, but if we don't have that environment and the capability to control it, we'll just never get there.
So a couple other steps when you begin crop steering. One, try to have pretty good monitoring tools. So obviously we really like using AROYA. And so in AROYA, you've got a dryback calculator, so you don't have to go in there and do a calculation in your head. What you can do is use the zoom function and say, select dryback. Basically go from your last irrigation to your first irrigation. It's going to pop up each zone's dryback. You can log that as a manual reading, so it's easy to reference later. Get used to, checking out your data on a daily basis and just making sure that your shot sizes are appropriate and your irrigation schedule, or that irrigation window, is shooting for the type of strategy that you're going for. So if you're a little bit more generative strategy, shorten that irrigation window up. If you need a more vegetative, go with a wider irrigation window. And that's kind of the beginning of it. Obviously, if you are an AROYA client, spend some time with our client success managers. Jump on a call with Seth over here, or get Noah on the line, and kind of talk with them about what parameters that you're operating on right now, and some of the first steps to jump into crop steering. I always recommend that you kind of avoid manipulating too many variables at once. And so that's where we look at, hey, let's get the environment set up, and then start working with irrigation scheduling to hit the appropriate drybacks, get that EC stacking when we want it, drop it down based on some runoff numbers if we need to encourage infrastructure in that plant, leave stalk stems for vegetative growth, or later in the cycle hit some bulking. So once you've established those reproductive sites, the buds, then let's relax that substrate a little bit and get that plant to pop.
Great. Back to basics, right? Our next question comes from the chemical grower. They want to know, is it possible to crop steer with bottom feeds?
Bottom feed, I'm guessing I think we're probably talking about flood and drain.
Yeah, or there's a few different bottom feed pots on the market, and it is possible, but it's not possible to be nearly as precise, is the way I would put that. We can, narrow up irrigation times a little bit with that, but we just don't have quite as much control because we're, relying on the media to wick that moisture up rather than dropping off a specified amount on top. So when we flood that flood and drain table, it's hard to meter even by, the amount of time how much water is actually going to get taken up.
And so we've got some clients that do flood and drain fairly successfully using AROYA for crop steering. Sometimes they'll be in a little bit smaller media because when you are flooding, you're getting to a super saturation point, and it's also a lot of flood tables on the market aren't necessarily set up to be 6 inches deep when you flood. If you can flood, the higher up on the block, the better, because what is happening when we top irrigate from a drip stake, for example, is one, we're actually pushing the old, maybe slightly imbalanced nutrient solution out of the bottom if we are doing some runoff. And even more importantly, we're pulling oxygen through that substrate. So when that water comes down through the block, it's going to be actually creating a vacuum, which is pulling some from fresh air, some oxygen down into that root zone. And anytime that we see some roots that are a little bit brown or they're dying off on the edges, a lot of times that is happening in an anaerobic substrate, and so they need some oxygen to stay nice and white and achieve maximum growth. Few things that are happening when we're working with flood and drain is use that sensor reading to kind of time out your flood events. And so if you are crop steering in any scenario, you're going to have multiple irrigation events per day. And with flood and drain, it's really critical that you're keeping an eye on those drybacks, especially if you are in a smaller substrate. And it's going to be a little bit more fine tuning probably on making sure that you can use that smaller substrate without drying back way too far when you're pushing for generative growth.
Yeah, I mean, some of the best success I've seen with that, Jason, has been smaller plants, smaller media, and not trying to overgrow your capabilities with that flood and drain system, just because you are limited on, for instance, if I want to put on a 1% shot, that's going to be difficult. So my strategy changes a little bit. It's going to be harder to go vegetative. It's going to be way easier to go generative to an extent, right? Because also we have our midday dryouts. So yeah, it's just a little different, but it is totally possible. And you're just going to spend probably a little more time day to day dialing that irrigation in, as Jason was mentioning, watching your graphs and seeing when that happens, because it won't be quite as fast.
Yeah, and another thing to kind of keep in mind is obviously when we are looking at those graphs, after you begin draining, you're going to see a really steep slope from the water basically running out through the bottom of the block. And so it just takes kind of a little bit of training as far as getting used to those graphs and understanding, hey, this is when we're at field capacity rather than a super saturation, and run your transpiration calculations off once that has happened rather than immediately when you begin flooding.
Awesome. Great answers. So we've got Jody on with us today, who posted a question, some notes here. Jody, you want to unmute yourself and go ahead and speak to it?
Sure, absolutely. Am I unmuted here?
You are. We hear you.
All right. So last week you guys had a caller who had mentioned they were reducing the amount of 1400 in their Athena Proline nutrient solution they were running.
Mm-hmm.
I think after the third or fourth week of flowers when they were doing it. And they've noted an improvement in the quality of their flower while also minimizing or maybe even eliminating the dark green leaves with downward curled tips they've been experiencing. So my question is, I guess, is this common practice? I see a lot of charts, at least from the nutrient manufacturers, where they're suggesting the same solution from week 1 through 7, which equates to maybe around 150 parts per million of nitrogen. So in my simplified view of things, and maybe it's wrong, I correlate nitrate or nitrite uptake with transpiration. And if that is then the case, perhaps these charts are suggesting we kind of steer how the plants use the nutrients through VPD, PPFD, maybe even irrigation strategy. Am I onto something, or am I kind of manufacturing my own answers?
I mean, a little bit. So as far as nitrogen is concerned, the reason we want to start dropping that after stretch is the plant needs nitrogen to build that framework and bulk out. But when we're talking about nitrogen, we also have to realize that it itself can be a plant growth regulator. So excess nitrogen late in the flower cycle is going to cause more vegetative growth. So we're going to see darker green leaves, bigger inner nodes, looser buds, and then eventually other toxicities, because as the plant needs nitrogen, we're pushing that plant to grow vegetatively, has an antagonistic effect where everything else is now a limiting factor since we're having an overdrive at the wrong time. So that's why you typically want to, lower your nitrogen after stretch going forward. And then, the plants we can kind of push mainly through light intensity, how much nutrients they're going to uptake. But we can only push the plants to a certain extent. They take up what they want given the environmental conditions, and then everything drops out. So if we don't have enough light, we're only going to take up so much. If it's too cold, only going to take up so much.
Yeah, and that's great. I mean, kind of answer the second part of your question there. Adjusting or altering nutrient mix, maybe not on transpiration, light intensities, VPDs, but probably based on plant life cycle. So just kind of breaking that down more simple to what Seth was saying. One of the things that I think probably doesn't get said enough in the industry is, check out Moodler's chart, where you can see how those antagonistic effects of different nutrients can affect each other, and kind of simulate in your mind how those elements are affecting the plant growth. It's a good way, just dig in, and it sounds like you're doing a good job trying to ask the right questions for how nutrition can affect plant growth. And there's a lot of science behind it as far as traditional agriculture goes, and most of those practices can kind of be applied to cannabis. It obviously is a very hungry plant, and so we're operating on quite a bit higher nutrient levels than most other crops. So kind of keep those things in mind. But theory-wise, most of those previous researches have been where we build our knowledge on cannabis nutrition.
Yeah, it's still just a plant at the end of the day, I always tell people, if you can grow some killer tomatoes anytime, any place without splitting the ends, you could probably grow some killer cannabis as well.
Jody, thank you so much for submitting that. Did you get your questions answered?
Yeah, absolutely. That adds a little bit of clarity. I would ask one other thing then. If we are to be adjusting, basically the calcium nitrate we're adding to our solution based on the phase of growth, what do you think an amount to adjust by would be? 20 parts per million, 30 parts per million, so I can know kind of how to adjust.
Ooh, that's a tough one. Those small 20 parts per million adjustments are probably the way to go, gently. But a good way to look at it is just honestly looking at some of those different lines. Like, the different manufacturers do have different strategies about pushing nitrogen later on. And, some of that honestly is because just 5 years ago, it was a lot more difficult and expensive to be manufacturing and selling cannabis-specific nutrients. Now there's a lot more money behind it. We have a lot more complete nutrient lines, and less knowledge is generally required by the grower to be successful with these nutrient lines, just because they can be cannabis-specific. Less and less are we having to add CalMag or any other supplements like that, just because, hey, we can do research on this now. The companies can put out a product that the consumer actually wants. And that's really to all of our benefit, I think.
Beautiful, beautiful. Thank you, guys.
Jody, thank you so much for asking your question. And to everyone who's on with us today, we love hearing from you live. So if you have any questions, feel free to type them in the chat at any time so we can choose you and you can ask the experts right away. Jody, make sure you stay on after the broadcast. We have something we want to send you. Thank you for participating. I have my next question here from Instagram. This one comes from the Garden Consultants. They want to know, what is the max water content for a Friday Hugo GR32? I soaked them and some read 80%.
What was that? A Friday?
Friday Hugo GR32.
So 6x6x6 Hugo, I'm guessing. Yeah, 80% is not surprising for a freshly charged block. Anywhere from 65 up to 85 on Rockwool when we're hydrating it is typical. It probably won't stay that high once you have a plant rooted into it. But again, a lot of that comes back to every time you get new medium, it's a great practice to hydrate and test it and see what kind of water content you're working with. Because, in this world where manufacturers are scrambling to keep up with supply and demand, there's variation in the product. So like if we're looking at cocoa, even Rockwool is a lot more consistent. But you've got to remember, this is still made by people. It's, still a manufactured product. There's variances in the machinery that make it. So every time you get a new batch in, and honestly, every time you go to hydrate blocks and transplant, it's best practice just to test that and see where you're at. Because whether you're at 65 or 80, that might, affect how long we wait for you to dry back or the range of dry back we can work with. But we need to establish that baseline so we can see what kind of parameters we're working inside.
Yeah, that's exactly right. And one of the things I always try to reiterate with people is that exact number's not necessarily a huge importance to be tracking. So don't get caught up if that number's different from one run to the other. And that's why your probably best option is to kind of test that and understand the uniformity across the sensors that you have installed each round, and really pay attention to the trending. How are those plants grouping together? And over a time series, how are your drybacks, your irrigation events compare one to another over those durations?
Yep. We could take a lot of numbers off those graphs and still get a lot done. Would be a good way to put that.
Excellent. All comes down to the data. All right. My next question comes from Bisco Paul. They want to know, how important is runoff pH?
It's pretty important. I mean, it's something that I take every day. We talked about this a little bit in last week's episode. Obviously, pH being potential hydrogen, so measuring the ratio of positively charged ions to negatively charged ions in solution. Obviously, usually in something like Rockwool, we want to be going in at that 5-6 range. Something like cocoa, you might be up in 5-9, maybe 6-0. And so if our plant is feeding and it's eating up an imbalance of nutrients, we'll see that pH rise or lower. And that's a good indicator that maybe you're not feeding enough, or maybe there is a better option for a new nutrition composition that you could be feeding.
Yeah, I think you nailed it. When your pH starts to go off like that, it usually means the plant's preferentially taking up one thing and leaving another. And that's what we're balancing or fighting there with that. And I think the biggest thing is to look at, if you can get a test on your water, see what kind of ppms you're putting in of everything, and then, fight that initial reaction to go, all right, I'm watering at 5.8 or 5.7 and it came out at 5.2. I'm going to freak out and now start watering at 7 something.
Don't do
that. Stay with where you're at and still read your plant. There are some plants that will run off at 5.2 and stay fine. And that's just because they're eating a lot of food. And that pH, the biggest factor it plays in the ranges we're talking about is plant nutrient availability. You're not going to, if you stick your hand into something that's pH 4.8, it's not going to burn your skin off. It's not going to burn the plant roots off either. But the plants will not be able to take up almost any nutrients at that level. So that's the thing we're looking at. If you've got an imbalance there and an accumulation of the wrong salts, you're going to see that pH drop. And a lot of it will go back to nutrient composition and maybe some strains that don't work with the same nutrient lines that your other ones do.
Yeah, and so anybody that's watching this, if you haven't been looking up nutrient solubility charts in regards to pH, jump on Google. There's lots of them. There's very many that are substrate specific. That's going to be super important for understanding, hey, where is the right pH for me to feed at depending on my substrate type. So obviously if we're going into organics, our pH needs to be a little bit higher for the right amount of nutrient availability. And kind of another advanced topic on this that I encourage people to think about is modulating that pH just slightly throughout the plant life cycle to provide a little bit more solubility at different points in the life cycle. So we were talking about decreasing some of the nitrogen later on. We could step up that pH maybe a 0.1 or a 0.2 towards the end of the cycle to actually reduce the nitrogen uptake simply based on those plant parameters.
Yeah, absolutely. And that's a great way to kind of deal with, a single nutrient solution, let's say, going all the way through. And that's part of why they're manufactured that way. That makes it easier for the grower. It's less variables that you have to manipulate. And yeah.
Just trying to make your lives easier, growers, all
Yep.
about it. On the subject of pH, I have another question on this topic. This comes from Gabo TRXP. Apologies if I got your handle wrong. But they are asking, how do you balance pH when runoff pH differs from the input? How much is a normal upward?
You know what? That is a tough question. I usually, if I'm seeing, say, more than, say, and then rock wools, if I'm seeing above 6.3, 6.4, then I'll start to get concerned. Definitely check out the stems and leaves. Are they showing a little bit of coloration that could indicate nutrient issues? And obviously, the absolute ideal way to identify any nutrient imbalances is shipping in a leaf tissue sample analysis. Send it into the lab. They'll break it down, and it's going to give you a more comprehensive understanding of what nutrient issues that plant is running into.
Yeah, that's the only way you're going to get really far with that, honestly, because the reaction time and, the results that you see on making a nutrient change aren't, observational science on that level is very tough. It's not going to work out. If you've burned a plant or given a plant a deficiency in that life cycle, you're not, in that specific flower cycle, you're never going to correct that. You might fix that imbalance and the plant's healthier from there on forward, but, those leaves that are burnt are never going to turn green again. So really it's just, trying to parse that apart and not just take guesses at it.
And as we're always saying, the better you can document this stuff, the better it is for continuous improvement. When you get that leaf tissue sample analysis back, take a snapshot of it. If they send it to you in PDF, upload it to your harvest group as a note. And so, you see similar results again, go back into the other harvest group and say, okay, well, here's what our tissue sample said about that growth cycle. We modulated something. Is this one fix it? Did it get worse? How can we compare from the results?
Yeah, and a picture really is worth 1,000 words. Once you grow the same, a lot of you guys know this, you grow the same strain 20, 30 times, and you go, oh yeah, I remember that one time that weird thing happened? Well, if you don't have it documented really well, we're all super busy. It's hard to go back and find that and then really nail it down, Because some of these problems too, you might inadvertently have them pop up here and there, but they don't happen every run. And that's when it gets really difficult to go back. You're like, well, I think we did this. Like, no, let's go look at it. We'll see pictures of what the plants looked like when we tried that. We won't just kind of toss it up and go, I don't know what's going to happen. Let's try it.
Great. Our community submitted a few EC questions, so I'm going to get into those next. Just a reminder to everybody who's on with us today, if you have any questions, please type it into the chat so we can get you a chance to ask it live. So Lonely Bones asks, why stack versus increase EC in solution in beginning of flower?
Stack versus increase. So when we're stacking, we are increasing. I think stacking refers to the way that we step that up through different irrigations. I don't know. Your thoughts on that? I think.
Just to
Are you talking about feed EC? I guess.
Yeah,
Is that
that's what I was going to dig
Yeah.
into. Is
All right. Yeah, we can go into that.
A lot of times, we typically feed at about the same feed irrigation for most of the flower cycle. Maybe towards the end ripening, we'll drop it down a ways. But the nice thing there is, if you've got lots of different rooms on one dosatron setup or one fertigation skid, you can all be going in at 3.0 or whatever your specific ideal feed EC is. And simply by modulating your irrigation volumes and your irrigation windows, you can kind of change how much runoff you get. And that's our favorite way to modulate substrate EC, and it's kind of one of the reasons that the AROYA system has been so very effective with crop steering is because you can kind of step it up just based on decreasing your runoff, running only P1 events and pushing a nice generative pressure onto those plants, letting that EC rise up for the right duration based on that strain and your planting cycle. And then you don't even have to necessarily change your input feed, and you can drop that back down simply by opening it up that irrigation window and possibly pushing a little bit more runoff.
Yeah. Honestly, save money and time and sanity. If you're chasing your feed EC around, you're really varying a lot. And, if you're first trying this out and you've got, let's say, just a hose and you're pouring nutrient solution on and you're really flushing it basically every day, your root zone pH is going to be close to what that feed pH is. And that's where a lot of that theory traditionally comes from. If you can keep it at that 3.0 to 3.5, what we like to run, as Jason was saying, you can modulate that. And if I'm mixing up 3.0 versus 6.0, I'm saving a lot of money that day. And then I project that across an entire growth cycle. Suddenly it's a lot more economic to be able to modulate my root zone pH via runoff modulation.
Are you talking pH or EC?
EC, I'm sorry. Thank you, Jason.
I don't want to get people running 3.0 pH. That might get a little rough.
Thank you. But yeah, so that's another way to think about it too, is just economics. Like, do you want to mix up that much nutrients, or is there a better way to do it that's going to save you money?
And kind of to reiterate some of what he was saying as far as chasing your feed EC around, as far as going on a complex feeding chart. Anytime that we introduce more complexity into these cycles, more chances of mistakes being made. So if you are every 2 or 3 days doing something to your feed EC, there's way more likelihood that you're going to go into a mixing issue simply because you're doing something different every day, and or you're changing the parameters on your skid probably more often than you actually need to. So reduce some of that complexity, reduce your labor, increase some of the reliability going in.
Yep, absolutely. Keep it simple.
Keep it simple. Yep. I've got another EC question. I think you guys touched on this a little bit in your answer, but Isaac 209 wants to know, when stacking EC, what is the highest you want your EC readings in the media?
So a couple things, and this is why time series data is so very valuable, is when we are stacking, we're going to see a pretty significant rise in EC from when we do irrigate to the end of the day or the next morning before we irrigate again. As far as what's the highest, I don't get too scared if my peak before irrigation is up in that 15, maybe a little bit higher. As far as where it's coming back down to when you irrigate, that's where you can use the AROYA crop steering quick start guide to kind of judge where you should be at, depending on time frame, substrate type. Lighting type is also going to be one there that we want to consider.
Yeah, as far as max EC goes, looking around, I've been completely surprised sometimes at looking at how high people are running. But also, one thing to remember is that difference between that EC, or that difference in the EC swing between, say, 25% water content and 20 or 21 can be huge. That line is very much exponential and not linear. So you could be maxing out at 15 all along, and then, wow, your plants are taking up just a little more water. Suddenly you wake up one morning and go, wow, it hit 21. but that's not necessarily a horrible condition. It just means we might want to address that severe dryback and run a little runoff, get right back in line. It's a highly, highly strain dependent thing, I've noticed, like more so than I ever would have thought of before being able to view a lot of this data.
Yeah, it absolutely is.
Okay.
That's kind of where you want to keep an eye out, document things as best as you can. If you got a heavy feeder, let it eat.
Mm-hmm. And remember too, eventually once you start compiling this, there's going to be strains that you cannot run together for that reason. Their nutritional needs are just far too different. You know, I've run some light feeders that if I give them not any amount of nitrogen, but anything that seems like I'm trying to push it, they just get huge and stretch like crazy. And I can't run those with something that's like a squatted heavy feeder. It just isn't going to work ever.
Yeah, great. I have another question here from Instagram, but just a reminder, we had a couple people just joining us. Welcome. If you have any questions, please type them in the chat. We would love to answer them for you live. This one comes from Northern Grown Trees, and they're asking, what's the optimal EC of my medium while in veg? Now, they did not say which medium they're using.
Gotcha. Typically, whether I'm in Rockwool or Cocoa, I want my average in media EC to be about 4 by the time I hit flower. So in veg, oftentimes our challenge is getting from that, you know, maybe we're feeding a 2.0 or somewhere down even by a 1.8. We want to be able to stack it in veg, which can be tough when we're applying vegetative steering because it can be tricky in a small substrate, especially to back off our water content and then apply those vegetative cues all day without pushing more runoff. So I like to say 4 is a good goal. That's not a uniform rule, but that's usually a good goal to start with hitting by the time you get into flower. Typically, it's going to start at whatever you charged your block or your media with, and you're going to go from there. Avoiding too high of EC in veg, though, is pretty ideal because that means they're not getting enough water, generally speaking.
Yeah, and this is, again, where we always want to have people consider that when we make these recommendations, it's just trying to get a general good starting point with the information that we've given. So, there's a ton of other variables that our agronomic advisors talk to you about when we ask a question like that, or we answer a question like that in our one-to-one training sessions with clients. And so that kind of gives us a lot bigger picture. And I do reiterate, that substrate size is one of those that's probably at the very top of this list. When we think about nutrient concentration, we also want to think about the total amount of nutrients available to a plant. So if we're in a really large substrate, sometimes that nutrient content needs to be a little bit lower, simply because there's so much more volume that the plant has access to a lot more bulk amount of nutrient. So anytime that we have, more solution, so let's say I put 10 grams of salt in a gallon of water. Well, if I put 10 grams of salt in a half gallon of water, there's the same amount of nutrients available in that volume. It's just that the half gallon is going to be twice the concentration. And EC is a concentration of nutrients.
Mm-hmm. Yep.
Great. All right. So continuing the conversation, now we're moving into irrigation. Brad A85 asks, does the irrigation matter if the environment can't be controlled to that detail?
How much time do you spend walking around every morning? Because even if you don't have perfect environmental control personally, I spend enough time hand watering to say that irrigation's worth it no matter what. But if you can't get a handle on your humidity, VPD, temperature, depending on which way that handle swings, that you can't get a hold of it, you're either going to mold out your crop or suffer some pretty reduced yields compared to what you could be doing.
Yeah, I mean, you and I both know on more home grow type situations, or even in facilities where there hasn't been enough infrastructure investment, environmental challenges are really they're a real thing. I mean, when it kind of goes to the point where how much time and energy you have into growing those crops, and then how much do you want to invest in making that as effective as possible. So just kind of think in your mind about the ROI on improving the equipment needed for an environment that is tight.
Yep. Even from the standpoint of looking at a cost benefit analysis, saying, okay, this irrigation system may not necessarily improve my yields immediately, but now I don't have to pay someone or pay myself 4 hours a day to walk around in water. That can be huge. And at the same time, it's just collect as much data as you can to do those cost benefit analysis. You know, if you don't have enough data, all you can say is, well, I got 1.5 pounds per light. Why? Okay, why? Well, we have to quantify every part of that to make an effective cost benefit analysis. Again, if you think the irrigation is going to solve everything, but you can't control your VPD, you might be better off spending money on dehumidifiers or HVAC of some sort to get your VPD under control so you can utilize that irrigation system.
Great. Excellent. This is so educational for me. All right. My next question comes from Midwest Cultivators, and they want to know which parts of bloom are you generative steering? And then they ask the same question for vegetative steering. It's a hard word to say. So which parts of bloom are you generative steering and vegetative steering?
So we hit this one probably 3 or 4 times in previous office hours.
Yeah.
So I'm not going to dig too deep in here. We did talk about it last week as well. Usually it's going to be very strain dependent. It's going to be slightly dependent on how long you're actually running that cycle. So on one end of the spectrum, maybe we're crop steering some MAC 1, very stocky, stubby type of plant. Genetically, it's already leaning more generatively in its growth. And so, we may have just a few days, maybe a week and a half max of generative steering in that. And our favorite way to do generative steering in bloom would be after the plants have rooted into their final substrate volume. So if you have rooted in to your final substrate in your 18-6 vegging cycle, then you can go generative right when you flip to 12-12. If you transplant at the same time that you flip to 12-12, then you probably want to make sure that those plants are well rooted in before you do start generative steering. So that ideally is going to be around that, say, 7-day, maybe 10-day mark if you don't have plants that are raging yet. So on the other side of that spectrum, for maybe something like a Blue Dream, a tall, stretchy plant, then that plant might actually have a longer cycle, and we're going to need to definitely cue it to stay tight, internal spacing tight, and run some generative for maybe 4 weeks, 5 weeks, 3 weeks. Again, there's so many factors in there that the best way you can determine that time frame is tracking your plant heights. So go in there and take a plant height measurement on the plants that have sensors, get that into the AROYA system. It's going to log it to your harvest group database. And when you go back and look at it, you can say, hey, we didn't necessarily push generative long enough for this plant, because when we switched back to bulking, we saw our internal spacing and plant height shoot back up a little bit. Had a client and, working with a new strain, went to bulking a little bit early and saw a pretty significant increase in plant height just simply by switching those irrigation parameters. So log it per strain, and just kind of set up your harvest groups to help you. That's one of the reasons that we do recipes. So recipe is just a grow cycle template. Build out different recipes for your different strain types, and this will help your team kind of stay on the right target parameters for both environment and irrigation. And then when you need to, build another recipe, slightly modulate it, and or stick with what worked very well. So that's a great way to understand cycle to cycle. Here's the changes that we intended to make. Here's some changes that we may not have intended to make, and hopefully those show up as alerts if you've got your system set up well.
Yeah, I mean, one of the big things is just getting that data. So measure your plants, take a lot of pictures, and then one of the big things is you've got your standard recipe that you're working off of, hopefully. go into your harvest group and change that every time you deviate from that. So if you had a run with a new strain and you said, all right, we normally do our second de-leaf at day 21, but going back to the MAC, let's say, we might do that a little earlier because it's squatty. And we generally try for that second de-leaf at least for me, towards the end of stretch. So in that case, we're going to make a change and we want to track everything and keep it all in one place. So part of that's just being diligent about getting that data in there and then saying, okay, yeah, we waited. We vegged a day longer. We vegged 2 days shorter this time. We were in generative a week longer with this strain. Really start to get that strain-specific data in there so you can build on your own knowledge base and also know how those strains are performing in your exact system. Because even if someone gave you a perfect recipe and said, all right, here is your VPD you're going to run, your nutrition, your temperature, everything, sometimes replicating that isn't really that cut and dry due to different variables between rooms. It might not be something that you thought would be a big issue, but sometimes it can be. So it's more about, getting the data and making sure you have the tools to make these calls.
I always like to kind of think about 3 steps to, documentation. Complete documentation is going to have an outlined plan. That's going to be what helps you go forward and operate as a company. It's going to be what helps your team do the things that are indicated by a cultivation director. And then the next observation step would be application. So did we do exactly what was planned? Did we modify that plan a little bit while we're running based on some intentional implementations? And then the last step would be an observation of what actually happened. So, an outcome. If we planned to do this, we applied that, then what was our outcome there? And, I guess it doesn't deviate much from the scientific method where all 3 of those, the better they're documented, the easier it is to do it next time.
I love it. That's excellent advice. Well, we're rounding out the hour here. We have a few more questions submitted from our Instagram community. Just want to remind the folks who are online with us today, please submit your questions in the chat if you have anything you want to know about. Love to get to those today. Northeast Labs is asking, do you want to maintain full WC all day and just see your veg or gen dry back at night only?
No.
Not at all. So keeping that WC, like water content, up during the day is definitely more of a vegetative cue, but part of that is those repeated irrigations. If we're going generative, we want to have that short irrigation window, long dry back.
There it is. Excellent. Okay. I got another question here. This is from Ketchet Jan. I know I got that wrong. Apologies. What is the driest percentage you want your water content level in rock wool before dark period in flower?
So let's just abstract the before the dark period in there. Obviously, it's going to depend on your transpiration rate and your substrate size going into the dark period. So we'll just take that part out of it. For rock wool, we usually don't, at the very lowest, want to see anything lower than 35%. So as a target, I never want to be lower than 40% just to give me a little bit of buffer there. And so, usually, let's say before the next day's irrigation, if we're at 45%, say we're running slabs, if we went from a 70% to a 45%, that's a pretty generative dry back. And so the best thing you can do if you're going into overnight is look at the last day's nighttime transpiration, use that calculation and apply it to the same day. So that type of time series data makes it much easier to answer those kind of questions on where do we want to be at a specific time throughout each day cycle.
Yeah, and it's important to be able to look and see overnight what your room's doing. You can plan for a dry back, but if suddenly we've got humidity issues, well, it changes everything. Or, if we've been hoping for 10% dry back and all we've been able to achieve is an 8 because of overnight humidity conditions, that's 100% a factor in there. So there is no rule. The biggest thing to look at is where are you at before your first irrigation in the morning? About 2 hours after lights on, where are you at? Have you dried down too far? Because we really don't want to be applying irrigations until either the end of our generative irrigation or the end of our P2s in vegetative. We don't want to apply anything overnight or anything before we want to in the morning. So that's what's more important for sure than the end of the day water content.
Excellent. This has been such a great conversation. I have one last question from our Instagram community. So to the folks online, so a few minutes to answer your questions if you have anything after this one. But Andrew Garcia 4 asked, what is the last week flush taper irrigation strategy?
So again, I personally really like to avoid the terminology flush, simply because there's some undefined connotation historically in the industry on what that means. And so many times when people say flush, they're talking about straight RO water. In today's hydroponic medias, we don't necessarily recommend ever going to straight RO. And so I do like the fact that he mentioned tapering that in there. I like to refer to the period as ripening. So that ripening is basically the goal. How do you get to that goal? You can drop your EC, your feed EC a little bit. And the best part there is keeping in mind the amount of EC rise. So when we do that ripening, usually it's going to be a little bit more generative type of application. And so on your day-to-day, those plants are usually going to have really large drybacks, and that EC is going to go up drastically. So, possibly just before we're going into ripening, if we're running a vegetative irrigation strategy, we'll see nominal ECs during irrigation in the substrate and say maybe 5 or 6. Now, when we go into ripening, we could drop our feed EC down to 75% or maybe down to 50%, depending on how long you plan to ripen. We're going to see those nominal ECs drop a little bit, but we're also going to see the EC spikes be substantially higher than they were in veg, simply due to those dryback numbers. So, kind of keep that in mind that, hey, we can save a little bit of nutrient. We can kind of help make sure that plant finish is real clean. And also, one of the most important things there is not going straight to RO, especially in something like rock wool, that can be a significant change in what the plant is used to, and it can cause some cellular issues and cause some necrosis in those bud sites, and that's the absolute worst time to be withholding what the plant needs to get ready for chop.
Yeah, so to build on that, as Jason was saying, we really don't want to starve that plant out at the end. We don't want to cause anything. And one thing to remember is you've spent 2 to 3 months building it up in this saltwater environment. So the plant's been storing sugar in its roots to deal with that osmotic pressure and still be able to pull things through. So changing it right away is not good. One thing you can do, towards the end there is kind of taper down your EC, pull it back, say from a 3 to a 2.1 EC at a day at a time, don't do anything too crazy. But as you do that, I think the biggest connotation I've learned from flushing is not only going to straight RO, but physically flushing things through the medium. And that's not what we want to do. We don't want to drop all the EC out of the pot right now. And a big part of that is for post-harvest. If you take a physically weak plant into the dry room, it has a better chance of molding, just like it did before you cut it down. Weak plants are more susceptible. So we want that plant to go in as healthy as possible and not have any osmotic shock issues or anything like that.
Wonderful. That was my last question from Instagram. Looks like our online community is pretty satisfied. Jason and Seth, thank you again for such another great conversation and on St. Patrick's Day. Oh, wait a minute. We've got somebody raising a hand. Raul, go for it. What's your question? Can you unmute yourself? If not, you're welcome to type your question into the chat.
Yeah, I just bought me the Solus, and I'm running in the 6-inch half-gallon Floorflex Pro pots. What would be the best way to attach that to the Solus to the pot? Because it's a hard plastic on the side.
So if it's a round pot, it's a round hard plastic. Definitely try and cut a slot in there. So if we've got a round pot will want a horizontally cut spot, and we're going to make sure that that's at the right height in relationship to the installation tool. And one of the things that we're really trying to do there is make sure that the 3 prongs are as flush with the substrate as possible. And so if it's a square hard pot, sometimes you can get away with just pre-drilling some holes. Don't stick the drill bit like all the way into the soil though. Just drill through the plastic itself only, and then insert the tool, or the sensor, excuse me. And those prongs, if they're exposed to any air, they're not going to read as accurately as they could. They're very accurate in wherever they are. So if they're in air, then they're going to be reading more air, and we're trying to sample the substrate. So we want to make sure that the continuity between those prongs and the substrate is as best as possible.
Yeah, so some of the best success I've had with those plastic pots and talking to people, cut that little panel out before you fill your pot up, slap some tape over it, pot your plant up, pull that tape off, stick your sensor in, and then if you're going to do that to all your pots, do it before you start the run. One thing that's going to be helpful with that Solus, depending on how your benches are set up, might be to leave it in one pot and go turn it on periodically and get your readings so that it's the most accurate. Basically, when those probes are in there throughout the cycle, that plant is basically going to root around them. So every time we reinsert that, that's introducing variability to the equation. We just kind of want to reduce any of that potential variability due to just installation and run it in one pot ideally.
Royal, did that answer your question?
Yep, that answered my question. Yeah, it's my first time trying crop steering, so I've been watching all you guys' videos and stuff. You guys got great information. Keep up the good work.
Thanks.
Awesome.
Yeah,
we
thanks,
appreciate
guys.
you. We're here for you. Awesome. Well, Roel and Jody, please stick around for a little bit longer if you don't mind. And again, Jason and Seth, thank you for another fantastic conversation. Thanks to everyone who joined us for office hours this week. If you have any questions about AROYA or how it can be used to improve your cultivation production process, or any other topic you'd like to talk about in a future office hours, please feel free to post it in the chat. Send us an email at support.aroya@metergroup.com. or send us a DM on Instagram. We definitely want to hear from you. We record every session. We'll email everyone in attendance a link to the video from today's conversation. And then it will also live on the AROYA YouTube channel. So like, subscribe, and share while you're there. And if you find these conversations helpful, we would love for you to spread the word. But we look forward to seeing you next time. So thank you all so much for coming, and happy St. Patrick's Day.
Have a great day, everybody.
Bye, guys. Thanks, Keisha.
Thank you, guys. Good to see you.